In this video, we're going to be factoring trinomials where the leading coefficient is not 1. So, just like we factor every single case, the first thing we want to do is look for the greatest common factor. The second thing we're going to do is dictated by the number of terms. So we're going to be looking at trinomials, that's polynomials with 3 terms, and we're going to be looking at situations where that leading coefficient is not 1. So let's put an A there for every single one of these cases. And just like when we're factoring trinomials where the leading coefficient is 1, we still have the same situation when it comes to our signs. If we have a polynomial with 2 positives, the middle term and the last term are positive, then both our factors are going to have addition signs. If the middle term is negative but the last term is positive, they're both going to be negative. And if the last term is negative, then our 2 factors are going to have opposite signs. So let's look at an example. We have 2x squared plus x minus 15. Just like in the last video, we're going to be using the acronym FOIL. That stands for first, outer, inner, last. And we're going to spend most of our time focused on the outers and the inners. Let's start by factoring this. We know that we're going to factor this as a product of 2 binomials. We're going to be looking for factors of the first term. We have 2x squared. So we could either write that as x times 2x or 2x times x. I'll start off with 2x times x. That really doesn't matter what order you put it in if this number is prime. If we just have those 2 fixed, then we could focus on the last factors and we could just swap those around if we need to. So now we're going to be looking at factors of negative 15. So let's write that off to the side. Factors of negative 15. So we could either go positive 1 times negative 15. We could go negative 1 times positive 15. We could go positive 3 times negative 5, or we could go negative 3 times positive 5. And it looks like we've exhausted all of our factors. Now, in the last video, I gave a tip that said, take a look at that middle term. If that middle term is small, then we want factors that are close together. If the middle term is large, then we want factors that are further apart. There is a major caveat to that, though, because now we have a coefficient of our x squared term that is no longer 1, which means that when we check our outers and inners, we are going to get some multiplication here. So we're going to end up multiplying this, and if we have factors that are farther apart, well, we're going to end up multiplying one of them by 2, and that could make the end result even further apart, or that could make the end result a little bit closer together. So our rule that when the middle term is small, use factors that are closer together, that gets a little bit murkier. I'm still going to stick with it here, but it may not work as often as it would. So let's start with positive 3 and negative 5. So I'm going to put a positive 3 here, and I'm going to put a negative 5 here. I'm just starting there. I'm going to work my way down. If those don't work, then I'm going to work my way back up. So positive 3 and negative 5. So check my outers. 2x times negative 5 is negative 10x. Positive 3 times x is positive 3x. Add those 2 together. We get negative 7x, not positive x. That's not going to work for us. We could, in this particular case, swap these around now, right? Positive 3 times negative 5 didn't work. But what if we put the positive 3 here and the negative 5 here? Okay, so now we have 2 options, and the placement matters because of this too. right? This 2 really complicates things a little bit. So now we got to swap their placement. And now we're going to check the outers and inners again and see if we get our middle term. And if we don't, then we're going to go down to our next set of factors. So let's see, we have 2x times positive 3, that's positive 6x. Negative 5 times x is negative 5x. Add those 2 together, and we do get positive x. So by swapping our factors, swapping the placement of the factors, we end up getting a middle term of positive x. So off to the side here, you could just see those 2 factors, they gave me 2 different options. One of them is the one that I need here. So our final answer is 2x minus 5 times x plus 3. And again, you could check that by multiplying that all out. Now just remember, if that didn't work, we would have to go down to our negative 3 and positive 5. And if that didn't work, we'd swap that around. We would try positive 5 and negative 3. And if that didn't work, then we'd have to go up here and start using those other factors.